Okay, well, good afternoon. Great for you all to be here. My name is Vincent Oostindië. I'm a business architect at Rabobank. Rabobank Nederland. It's just you can see you cannot see the tower from here, but it's like 200 meters from here. I'm a business architect. That makes me responsible for the architecture of what we do at Online. That means our apps, our websites. We have about 30 teams at Online working at those components. We also deliver the online platform, which is being used all across the bank to build their stuff on. And well, we've been in a long transformation, or we're actually in the middle of a transformation now, which I'm going to tell you about. Yeah, hope you enjoy. If you have any questions, you can just shout out during the session. That's fine by me. If it takes too much time, I'll have to ask you to move to the back. But anyway, if you have a question that you think everybody else wants to hear as well, then don't wait. But make sure everybody else wants to hear it as well. Okay. So the online platform, what we actually do, and I'm going back now, in 2008 somewhere, this new site went live. This is any Rabobank customers in the room, probably? Yeah. This is about average, and so many people in 10 is a Rabobank customer in the Netherlands. This is Rabobank Internet Bankieren. We put this live in 2008 somewhere, 2009. And it's really much based on a platform that we have then extended, and I'm going to talk about it more. We've extended it into, for example, also our public website. It uses the exact same technical architecture. Later on, also our new app, which we have in since a couple of years now, but it's been constantly changing into new look and feels. And just recently, we've also been moving into a more modern website. Some customers have already seen it, I guess, maybe not all of you. What you see is that on the left and the right, it's basically the same thing. It looks the same because it is the same. It's the same technology, it's the same software running on both platforms. But that's not what I'm going to talk about. I'm going to talk about mostly the server-side platform of it all. So our online platform, that's been running since 2008 and is still running today. The way it works is very simple. I can explain it to you pretty easily. We have something called a deployment unit. And the deployment unit is a box of WebSphere, is a set of WebSphere machines, Linux WebSphere machines. And there's a load balancer in front. And it routes traffic, depending on the URL, to the right set of servers. So for example, your online banking features, getting a transaction timeline or making a payment goes to set A. And getting information on a loan is set B, for example. Depending on the load on the systems, we have a different setup of the deployment unit, so the amount of servers on each set. Well, it's pretty simple actually. It's all very old-fashioned. So this is we'll get into that. It's J2EE, but it's also it has session state, so it's very stateful. It has sticky sessions. So when you end up at some server during a session, you'll keep on ending up at that thing. But it actually does support multiple sites and multiple domains. So our app, our websites, they're all being served from the same architecture, actually from the same set of machines. But we have lots of them, so we're not too worried. They're all very independent. Each and every server is independent. Each and every set is independent. So one can fall down. We don't care. We just spin up another. Even though that takes a bit of time, but they're all independent, so it scales really easily. How the Java side looks, or the WebSphere Linux side of it, is what we call then our portal platform. So basically what it is we have a Linux box, we have WebSphere on top of that, then we have a set of shared libraries and plugins we built ourselves, and then every team, every feature, every application is an independent application that you deploy on WebSphere. So typically in the old days, especially in 2008, people would deploy one application on a WebSphere box, and if they had another application, they would deploy it to another WebSphere box. We have all the internet applications as small applications. So the transaction timeline, making payments, they're all small apps, and they all run on the same box. And there's a portal framework that we built ourselves, and we did not buy one, as you might expect. So we looked at the IBM portals, the Oracle portal platforms, but instead of buying such a big box with a lot of stuff in it, we just built the minimum that we actually needed. Well, how it works, every traffic that's coming in, all traffic goes to our own portal framework. Basically, it's /*, every request goes there. And depending on what's in the request, what's defined on the page that you want to see, the framework forwards the traffic to an app, to a separate app. Basically, this is your front controller pattern, what you would do in a Spring MVC app, except that it's extended to separate apps. And this allows us to deploy each and every app separately. So, and that's why we built it in the first place, that we have many teams building features, building apps, and every one of them can deploy it in their own time, separate from all the other teams. Well, we have a lot of generic functionality built in our portal framework since 2008, so we've been extending it. For example, you can think about access control, so who's allowed to access which pages or which features. We can do that in a central place, so in our portal framework. We have features like a user profile. If somebody logs on, we get all the information on that customer and pass it to each and every app that's running, so they don't need to fetch all the data themselves. We have an API for storing and reading preferences. We do very cool stuff with throttling, which fork join and all kinds of concurrency patterns to make sure that our system never goes down, even if one application goes out of whack, for example. And of course, we have a lot of monitoring built on it so that we can centrally monitor the whole platform. At first, it was really portlets. So it was J2EE with portlets on top. Well, for those of you who were still alive in 2008, or already programming, I should say, it's wrong sentence. So we're already writing software in 2008, and you know portlets, you know that it's all server-side rendered HTML. State is on the server. Every click is typically going back to the server, doing something with state, sending back new HTML. That's what we started with. In the meantime, we now do services a lot. Basically, all the new features we built still runs on this platform, but the number of portlets has dropped tremendously, and everybody's now doing services. So these spit out JSON, just data, and we have a rich front end, either native or web technology, which does the state and manages the view. So we've been transforming the application in that way. Because this is all a single box, everything that happens in the server is in JVM, and that makes it really fast. So we can build up a user profile or any data on a customer. We forward it to another app, but basically we're passing it just a Java object reference, and the other apps running on it can just pick it up and use it. It's really fast. And that's something that, with the coming of microservices, of course, which we'll get into, is getting a lot harder. This is what we built in 2008, been extending ever since, and it's actually running really well. We have over 7 of those deployment units. There are over 400 applications in total on top of this platform. It easily does 2,100 transactions per second, so on a busy day, there's a lot of logons. And on an average day, we have about 2 million customers logging on to these servers on this platform. And actually, in those 10 years, we have hardly had any really big disturbances. We've had a couple, actually a couple of months. We had one a couple of months ago. But before that, I can't even remember when there was one. So it's a very stable, very proven platform. But still, we're saying it's time. It's time to say goodbye. We have to quit with our platform. And there are 3 reasons for that, actually. The first reason to do that is the age of the technology. Come on, people, it's WebSphere, it's Java2EE, who does that anymore, right? Everybody wants to do Node or Python or Go or Java, but then on a Spring Boot app. So there's a much bigger proliferation of tools and libraries and languages these days, and we cannot support that. Our WebSphere environment is still, I think, it's recently being upgraded to Java 8, and it took us 2 or 2.5 years to upgrade the whole platform, because it's a very big, lots of applications on it, lots of big regression testing, so it takes a long time to upgrade the platform, and then we're only at Java 8, right? So Java 11 is around the corner, and we cannot simply do that. So that's one reason to move away, to give more freedom to use much newer technologies. Another reason is that we're actually reaching the bounds of our platform. So we have those 400 applications now, but it's actually, we're almost at the end of what we can do. So we can put more applications on a single box, but then, booting up a box takes a long time. We're getting memory issues on those boxes. So what we would then do is create a new deployment set where we would move other applications to, but that is, again, a hassle to configure in a load balancer. We get hundreds of rules of where to go to depending on the request. So it's simply not maintainable anymore. Basically, you could say that we're a victim of our own success, but it worked really well, but it's now getting really tricky. We already knew that it was going to be tricky when we started this whole platform in 2008, but at that time, this was the best we had. There was nothing better we thought we could do at that time. And we also thought, well, it will take a while before we have issues. Well, 10 years later, we have issues. A third reason for doing this is DevOps. And within the Rabobank, the last couple of years, I think it's already 5 or 6 years even, there's been a transition towards more agile development. We have been, since 1.5 years or 2 years, we're moving into real DevOps mode. So you build it, you run it kind of teams. And having a platform which is consolidated, so that's a single box where lots of applications run on, you cannot do DevOps, because everybody needs to be responsible for their own stuff. And if your stuff runs on a box that also runs other people's stuff, then yeah, then you can't be responsible. So any DevOps teams, all the DevOps teams say that this is not something we can do real DevOps on. We want to be responsible, but then we have to have the box ourselves. So that's one other big reason. So we investigated on what we should be doing, where should we go, and of course the obvious answer, you already know this, otherwise you weren't here, it's that we said we would need to go to microservices in the future. But that's a nice thought, but then we thought, well, if we do this, then you end up with something like this. This is the Netflix image of already, I think, 4 years ago, when you see a whole network of stuff and services connecting to each other. So if this is, and that's constantly the thinking that we do, we already have 400 applications, and not even counting the number of instances deployed of those applications. It's lots of servers, lots of applications, lots of instances. So how do you do that? So what you need is a platform, because you need to deploy your stuff, you need to run it, you need to monitor it, you need to isolate and operate your services and your applications independently. In other words, you need to be able to scale out. If we're really going to go the microservices way, then in a couple of years we'll have thousands of instances running in production, and then you have test, which is typically 3 times as big. How do you make sense of that? We decided pretty quickly we need a platform for that. So we went through a whole process of getting to our platform. We started with research, so I'm going to slowly talk through these steps. We started with research, and when we started, it was a lot of open source technologies that were coming up, like Mesos, Docker, Marathon. We had DCOS. There were all kinds of tools coming up. So we investigated those, and we actually built one as well. So we built our own platform, our microservices platform based on Mesos and Marathon, and we actually pretty quickly decided that this was not a platform we would want to go to. One important reason is that it's not multi-tenant, for example. What we expect is we have one big platform, hundreds of people, hundreds of teams, thousands of people are working on it, and they need to be able to do it in isolation. So you need multi-tenancy, that people can log on and see only their own stuff and manage their own stuff, and not see all the stuff from all the other guys, or worse, bring down stuff from other guys and girls. That would be even worse. Actually, the platform we have is still in production at one of the departments at Rabobank, at mortgages. Somebody is in the front seat over here. And it's actually running great. It's doing great, but it's really limited to that domain. We cannot scale that out to running it for everybody. It's simply not possible in the technology. Also, we decided, so we built this thing ourselves, and we also came to the conclusion that as a bank, we shouldn't be building a platform. We should just get one, run it, and deploy our applications on it. Because what it's about delivering business value, delivering apps, and not managing a platform. Not working out a platform with all kinds of Docker tricks and Marathon events and Nginx tools. We didn't want to go there, because it would mean people working on that every day, and well, that's not bringing any business value. So we quickly decided, after building our own and doing the research, that we would want to go to platform as a service, so PaaS. So that's what we started looking into. And we pretty soon found Cloud Foundry as an open source platform, which we really liked, and we decided to do a POC with that. And we did that in a non-traditional way for Rabobank. What Rabobank or any big financial institute would typically do is say, okay, we're going to do an RFP. And we're going to make this big Excel list with 10,000 criteria that the tool needs to fit. We're going to check all the boxes, and then we're going to do a selection. And then you have a very nice Excel document filled up, and actually you still know nothing. So what we said is, let's instead do a POC. We're going to pick the 2 top vendors we think there are for this platform, for Cloud Foundry. And if there's one we like, that's the one we're going to pick. And if none of them we like, no, well, then we have to look on. But so we made it pretty simple for ourselves. So Cloud Foundry is open source. Anybody not familiar with Cloud Foundry as a stack in here? Everybody? Well, yeah, so Cloud Foundry is, as I said, it's an open source platform as a service. You can find it at cloudfoundry.org. but they define a standard. It's not a standard in a way that there's an official body, but it's an open source platform, and there are multiple implementations of it. So you can actually go out and buy 7 different certified Cloud Foundry platforms. So that also feels nice. That was one of the things we liked, that if we pick one vendor and it would turn out to be really awful, we could still pick up our software, deploy it on another vendor's Cloud Foundry instance, and it should still work. Of course, there's a lot of details if you go into that, but it gives a good feeling at least. So we looked at Pivotal Cloud Foundry and at IBM Bluemix. Bluemix we obviously picked since we're Rabobank and we have a big contract with IBM. There's a strategic partner, so we cannot not look at IBM, I should say. And by the way, it's pretty good stuff. Bluemix is, so that's not, it's not like saying we had to look at it because we had to. It's actually pretty good stuff. And we also looked at Pivotal Cloud Foundry being the main driver behind the whole Cloud Foundry stack. They're also owners of Spring these days. So all the frameworks, all the libraries, all the Java stuff, they make it really easy. Anybody today doing Spring Boot, if you have a Spring Boot app, you deploy it on CF, it just works. And you probably don't even know it if you don't use Cloud Foundry, but it will. It will just work. So that's why we saw that Pivotal could really help us out with their platform. So we did a proof of concept, which was also kind of different than normal. What we did basically is, of course, we had a lot of criteria on what it should all do. But one of the very big criterions was that the developer should like it. So what we did is define a couple of use cases that we would like to build and like to see, and we let our development teams, not consultants from the vendors, but our own teams, build those use cases up on their platform. So they had a day of training, tell us how your platform works, and we'll try it out. And we do sprints, and sprint-based we worked on use cases. So it was actually the teams themselves coming up with saying, it was a large part in saying whether they like the platform or not. Because we can select anything we want, but if the developers don't like it, if you guys don't like it, you'll just go away, and we have a nice platform, or a technically nice platform, but no users on it. Makes no point. So we made it a very, very important aspect. So then we made a selection of one of the two, because we did like one of the two, and then we started implementing. Now, I work at a bank, so here's a bit of frustration coming in. This whole process took over 2 years. We started this at the end of 2015. So that is very frustrating, right? Every time you think we're almost there, there's somebody else coming up with lots of ridiculous rules that you need to comply to and everything you need to explain. That's what happens at a bank. So there's a lot of frustration happening here. I've been crying myself to sleep many times. But there's also a bit of silver lining in the end, so I'll get to that too. So what we did is, in the end, we selected Pivotal Cloud Foundry as our platform, and this is the marketing slide for Pivotal, of course. And not only as the replacement of the online platform, which is what we started with, saying we need to replace our online platform, but also actually we said this is the microservices platform for anybody in the bank. So whenever there's now a team within the Rabobank that needs to build microservices, or wants to build microservices, even if it's not going for online, this is their platform. So that's quite a big thing, and that's one thing that takes a bit of the frustration away, that once you've done something like this, the amount of people that can benefit from it is tremendous. And also, by the way, we are running this in the cloud. So we're not running this, maybe you know that Rabobank has 2 big data centers of themselves, in Best and Boxtel, but this whole platform is running in the cloud with Microsoft Azure, and we're slowly moving everything, especially starting with the online, into the cloud. Since that's our strategy these days. And in like 20 or 30 years, we'll maybe shut down our data centers. But it's going to take a long time. But this is the move we're making. 3 important lessons that I'd like to share with about the whole process. So I already mentioned them. The first one is, we're not in the platform business, and probably neither as any of you. So don't build your own platform. It's just a waste of time. It's much better to just get one from a vendor, install that, run it. It's much easier. Of course, it's cost more, but if you turn down the cost towards what your own teams should be doing, it's actually not that much more expensive. It's actually cheaper. So that's lesson 1. Lesson 2 is, the Steve Ballmer, it's as hot as here. I almost have these sweat stains now, but it's developers, developers, developers. If you pick a platform that's meant to be used by developers, then it's the developers that should pick the platform, not somebody else. So that's what we did, and I think we did a good job there. And the last thing, and that's what I'm going to get into a fight with some of you in the next slide, is that you really have to pick the right abstraction when you pick a platform. On that, it's all about abstractions. This is a favorite slide of mine. I've been using it for 2 years within Rabobank and guaranteed flames and bitch fights. So that's get it on. It's okay. So what we typically in the cloud or in any application, actually, when you do software development, there are exactly 4 ways that you can run that. And there are just that's the amount of abstraction levels there are. I've been asking towards many vendors what's going to be the 5th. So what's going to come after functions. Nobody knows. Everybody says this is it. These are the 4 abstractions. We used to all do VMs, right? So we all built our own. We managed our Linux boxes or whatever boxes. Did the patching. Did everything ourselves. And this was absolute flexibility. Whatever you needed, you could do. You could deploy some agents. Whatever you wanted or needed, user management, doesn't matter. Any tools you wanted to do, you could do. But it's also a lot of work. So the more flexible you get, the less abstract, or the other way around. If you need a lot of abstraction, the flexibility goes away. What we say is that you should always start from the left, always. So any use case you have, you should first look at, can I deploy this as functions? Can I build this as a set of functions? If the answer is no, you should look at the next step and say, okay, let's drop one abstraction level. Can I build this as apps? If there's a no, then you again drop another notch, and so on. What I see a lot in the community these days is that people are moving up from here to there. They worked on VMs for a couple of years, and they're now all doing containers. I think there's a session going on right now about Kubernetes, Istio, and I really have a love-hate relationship with that because it's very cool technology. It's very nice, but it's also an utter waste of time. Because at the same time, so what do we see? And this is where the fighting starts. We believe that 84.962% of our DevOps teams, and the significance tells you how much of a lie this is. Of course, this is just something, just a number, but it's actually the majority of the team. Most of the DevOps teams that we have at Rabobank, they deploy apps, they build apps. That's what they do. They build features for the app. They build just applications you use on the internet every day, and it's apps. It's based on apps delivering business value. That's what they do. Functions are really not ready for production deployment yet. There are actually very few use cases for it. We've done a workshop just last week on what the different function platforms available today, and they're all very immature still. So it's nice to do tryouts, but it's not yet ready for big-time stuff. So yeah, but then you drop down, and then you get to apps. So instead of going from the bottom right to the top left, we said, let's try top left first and then drop down. And then you end up at something like Cloud Foundry, and not at something like Kubernetes or Docker or any other big waste of your time. So what we're doing these days, so that's the promise that we give to our developers, is simplicity. What we're saying is you have a couple of constructs, and they're very simple. You have a CF command line tool. You can push your apps, and you get a URL to it, and you can scale them, and you have multiple instances. And of course, you can monitor, and that's about it. You have routes that point you towards your app, and you have instances of your app. That's about it. That's it. There's no containers. Of course, there's containers in there, because it's a very mature and very important technology platform, but it's hidden. You don't care. As a developer, all you do is you have your app, which can be a Spring Boot runnable app. You just push it towards the platform. The platform bundles it into a container for you and boots it up. And if there's patches on the VMs or patches on the root OSs of your apps, you don't care, because the platform does that for you. All you do is deploy your app and scale it. And it's did I have a question? No? So what we do is we've actually done this in the POC as well. We've been upgrading our PCF instance while the team was doing use cases, while the team was actively using it, and we can upgrade the whole platform without downtime. We can, it just keeps on running, and there's a lot of pipelines there to upgrade the platform or to do security patches or whatever. And as a team, all you care about is your app. For example, your Java app and your Spring Boot libraries, and of course you need to manage that. But you can throw away all the container stuff. So we did this in the POC. We saw that we first tried it with containers. We did a lot of Docker stuff and wrote all the nice scripts for Docker to get them to deploy. We also tried them on OpenShift. And then what we saw is when we moved to Cloud Foundry is just throw away 80% of all your deployment stuff, and it works. So it's just that much better. As a developer, you're going to be happy. People in the room who are not yet doing this will say, well, he's just talking out of his ass. It's not really true. But the developers in the room who are already doing this, they will vouch for this and say that it's actually that simple. Really, so find them later. So what actually happens is you push your app and you get an URL automatically, which is your app dot some large long wildcard, and you scale it up, and it runs on PCF in a container, and the platform manages where it runs on which VMs, and we can scale up the platform by adding more VMs just by pulling a slider. And in our case, we're running on Azure, so in the background there will be more Azure VMs spinning up. If VMs go down, the platform starts up new VMs and deploys your apps again. You don't need to do anything, except, of course, that in your monitoring, you should be seeing that your apps are going down and up again. But that's how easy we promise it to be. So, well, this is all nice. So this is what we promised to do. But now we have our current existing platform, which is, if you remember, WebSphere, big boxes, all the old stuff, J2EE. So now what? How do we migrate that? So we said there are two distinct tracks to do that. I'm going to talk about both. One is migrating our own apps, so the individual apps towards microservices, and the other is migrating features of the Portal framework. I'll first go through the apps. Actually, when we look at our online portal, many of the apps have already been migrating towards smaller bundles. So in the old days, and starting 2009 and 2010, deploying an app was really difficult and expensive. So what we did is we bundled a lot of web modules, so WARs, into single ears, and then you get a big ear, and then we deploy that ear. So that's not really logically separated. What we've been doing in the last few years already is move those over to smaller applications, where each application is functionally, you could say, a monolith. A microservice, not a monolith, a microservice. So, and this looks very simple. You see there's a few different names in there. But actually, this is already very hard, because you need to talk to your business. You need to think about what does my feature, my application actually consist of, what parts are there, and then try to break it down into functional pieces and build them in such a way that they're really independent. So but we've been doing that already. So if you look at many of the applications on our online platform today, they are already partially microservices. The thing that's missing is that they're not running in their own process, because that's another requirement of microservices. It has to run in its own process, has to be managed on its own. It's still a consolidated platform. So the next step, makes all the sense in the world then, is that we take each of those applications and migrate them towards actual microservices. And we've been doing that for a couple of months and we see varying results, but many applications are very easy to migrate, because they're already we've been doing a lot of Spring already in the last years, actually from the start. So many Spring MVC applications, you connect a Spring Boot to it, you change your dependencies, and you're already a big way there. So you can have, it's quite it's not easy, and there's a lot of stuff that comes on, but actually migrating an application from our online platform today towards a separate microservice is fairly easy. Where the trouble is, that so you now have real team autonomy, of course. Every team can run, and every team themselves needs to think about how many instances do I need of this. Because in the old world, there was this deployment set of boxes. It was your deployment unit. You deployed on it, and you get that many instances, and there was no choosing. Now for every team for themselves needs to think, how many instances do I need? And how do I monitor this? And how do I know when it's not getting any traffic anymore? So you need to do all of that yourself. And I've been calling out to teams for, well, 2 years already that this is also part of the job. So yes, you get a lot of freedom, and you're a DevOps team, and that's great, because now you can do all of those decisions yourself. But at the same time, you also get a lot of responsibilities back for it. So it's you build it, you run it. And a couple of weeks ago, actually, our whole PCF instance in Amsterdam was down, and a few minutes later in Dublin as well, because we made an operational mistake, and actually, of course, a stack of mistakes. And the worst thing is that nobody noticed. Luckily, none of our customers noticed, because there are not that many big applications on it yet, so that's okay. We didn't get to the front page of nu.nl, luckily. But the teams didn't notice either. And what would have been the better response would have been outright panic. If all the teams would have been crying out loud that their feature was no longer running and nothing worked anymore, but they didn't. They just didn't notice. So that's where we really learned that the DevOps is a bit more than now you got all the freedom and deploy your stuff. No, you also need to monitor it and run it, because that's what you wanted. So now you got it. So a lot of cool learnings that we're doing still with all the teams go into this maturity model where instead of deploying to a consolidated platform, you now get to do what you really always wanted, at least said you wanted, and also take the responsibility for that. So it's a nice journey. Okay, so that's for the apps. Many apps are quite okay to deploy. Then there's the portal framework that we have. And the portal framework, remember that was that front controller kind of thing where all the traffic came in and it forwarded your traffic to a specific application. It was, of course, it was built for a reason, and all the functionality in there was also there for a reason. So we need to decide what we do with all of that. So I remember, maybe you remember a couple of these things. It supported portlets, services, it did monitoring, page rendering, user preference, all kinds of useful features. But what do we do with that? So we said, well, there are basically 4 things we can do. Either we throw it away, so that's because it's simply not necessary anymore. Think about the monitoring or the throttling tools that we built ourselves. We expect the platform to do that for us now, so we don't want to rebuild that, just use what's there and throw away what we had. Lots of stuff was probably going to move towards microservices, independent services. So how do we break up this monolithic framework thing into smaller services that everybody can use? And there was, and this was a slide from when we started, we also thought, well, there's probably going to be a proxy kind of thing, because there's a lot of logic that we do on every incoming request, basically your front controller thing, like security measurements we take there, and we really want that to be there, so some kind of proxy thing. Later on we learned that the proxy is also just a microservice, so we could have made this into 3 parts, but when we did this we didn't know that yet. And the last thing is that maybe we could decide to move a piece of functionality into a library that people could then plug into their application. Well, if you've been following the microservices trend, you know that it's never what you should be doing. Libraries are a no-go, basically, because, for example, it locks your application teams towards a language. If we provide Java libraries, then you don't get to choose Node anymore or anything else, or then what? So you should try to limit the number of libraries, but still, at the same time, many of our teams do Java, have a Java background, so it sometimes makes sense to give them a library to do something well instead of everybody rediscovering it. So, but there's a good challenge there in not getting too many libraries. So that's what we did. We did a lot of thinking and did a lot of trying, and we now have something, a set of, so that old portal framework is now called our Rabobank Online Cloud Services, or ROCs, because it rocks. That's not me who invented it. It was the team that came up with the name. And you see that a lot of features that were actually basically in our old portal framework are broken up and are available now as separate microservices. I'm not going to go through each and every one of those. For example, I can mention there's something like session store, right? That's awful because you don't have sessions, right? Because it's all stateless. Well, in reality, there's often still stuff that you need to maintain on the server during a session. So we offer a service for that where you can store and retrieve data on the server side only for your session. Well, horrible, but you just need it. Yeah. What I want to talk about is the edge router. So I'm not going to go into the other ones because that's actually the proxying kind of thing. That's why it was drawn at the top. What is the edge router? So maybe you remember when you push an app to CF, you get this really weird URL. That's something we will never expose to our outside world. So we need to route that in a good way. And the typical thing you do there is have an edge router, which is basically a microservice which handles all incoming traffic and then decides where it needs to go to based on the URL. And when you have that, you can build in lots of security stuff on that side. So for example, user authentication. If we know beforehand that the URL, that the service you're trying to access requires a customer who has just used his old-fashioned Rabo scanner with a high level of security, if that service requires that, we can already see when the request comes in whether that's the case or not. And if not, then just block it. So it's additional security measurement. Another thing is that we can have governance on our URLs. We call that the URL police, and people really hate that. which makes all the sense in the world because you're a feature team, you develop a service, and you just want to expose it to the outside world. But as many of you are developers here, you know that developers are bad at least one thing, and that's naming stuff. So what's important is that we, as a set of URLs that we expose, it makes sense. It should be it's a public namespace with many URLs in there, many services, and it should be a cohesive set. And if we allow each and every team to define their own URLs, it's going to be a big mess. We have proof of that as well, because that's currently in production. We have lots of those. So with this URL police, we have a way to govern the URLs that we expose to the outside world. And we actually set that up in a way that teams can just send in a pull request for the new URLs they want. We do some automatic checks on it, and there's a small board of people who can just say, approve the pull request, and a couple of minutes later it's in production. So it doesn't need to be difficult, but it's good that it's there. Another thing to mention, for example, is the red button procedure. It's also a nice thing, is that typically if you have a microservice, and let's say your microservice goes out of whack, it does weird stuff, it spits out errors all the time, there's a backend getting issues, how do you fix that? Well, one way could be to stop all your instances, but that takes time, or undeploy all your instances, that also takes time. So we could also just say, at the front door, don't allow any traffic to that application. So that's what we call then the red button procedure. If we know there's an issue with some kind of backend, we can just easily configure that those services don't get any traffic anymore, and done. You can keep everything running, you can look at your logs, you can do your debugging, you can fix your issues. So those are examples of what we do with our edge router. So how it works, basically I already said that, is we have a public URL coming in. Let's say you want to have the balance of your account. It will go to our edge router, it will look up that URL in our registry, and it will see that it needs to go to the balance application, and that application requires at least a customer who has logged on with at least level 2, which means you have provided your TIN code, for example. And by the way, it's enabled. So then it will see if the current user is actually the right level of user. If not, access denied. If it's disabled, access denied. And if it isn't enabled, we just forward it to the internal application, let it do its thing, and then return the result of that. It's very simple. It also allows us to do another thing, which is, how many people do Spring Boot already? Spring Boot, yeah, lots of people. And you use the actuator as well? Many people, yeah? And how many of you make sure that you put authentication and security on your actuator? Ah, that's a few less already. So that's typically what happens, is you plug in all kinds of cool tools in your service, but then you forget about security. And of course, these kind of metrics that your service, that's very useful for your service, which is what the Spring Boot actuator allows you to do. It allows you to build your own metrics, but also look at system metrics. It's all built in, it's great. But if you don't do anything, it's going to open up to the public, which is probably not what you want. And by having this edge router up front, the only way to get these things in the public is if there's a rule for that here, if there's a mapping to it, which of course we block. So that's an easy way to, what we call security in depth, to make it a bit more secure. If there's a developer who sometimes forgets, because you never forget stuff like security, of course. Never. So if somehow you still forget, then we can fix it this way. How we built this thing is it's a Spring Boot app. It's Java 8. It uses Netflix Zool, which is the Netflix. I don't know many people you know it, but this is what Netflix uses as well. Netflix recently released Zool 2 to the public, but at the same time there's this thing called Spring Cloud Gateway, which is an alternative to Netflix Zool, which is what we are looking into to replace this with. But it's all Java, and the edge router is just an app being managed by a DevOps team that manages the configuration, does the monitoring, does everything themselves. And they decided on the tools. So it's not that there's this business architect like me or a solution architect saying you should build it in technology A, B, and C. It's you're responsible. Find the tool that works best. And sometimes people say, well, let's do Python then, or Perl, or Ruby, or whatever. And that's fine, but we will have a discussion first. And the discussion will go about, okay, how many people in your team do know this language? And if it's just one, how are you expecting to maintain it over the course of the next few years? How mature is the environment you're running in? For example, for Java, we have a lot of automated tools that check the security and the quality of your code with tools like Fortify or check marks and stuff like that. That's not available for all languages. Still, you need to do that. So how do you do that then? And if you have an answer for that, then it's fine, then you can go. If you don't have an answer, then you maybe should reconsider. So we don't want to enforce people to do Java only, or we want to allow teams to make their own choices, but there is a discussion. So, and that's I think, the better way to get to the technology choices you make. On the side here, you see Cloud Foundry services that are available by default. So, for example, we have the config server, and we have the, I forgot what it's called, the circuit breaker dashboard. So the edge router sends traffic to all kinds of services, and the built-in circuit breaker from Cloud Foundry will block traffic if your service is starting to behave weirdly and stuff like that. So it's all part of the platform. It's pretty easy to use, and the teams really love it. And the last one is Micrometer. That's where we put our metrics in. So all the data we spit out on how many requests are going in, how many of those are errors, which application does it go to, how long does it take. Yeah?
Are you taking into account with the Spring Boot 2.0 the Micrometer is also an integration of that?
So can you repeat the question, and I'll repeat it again? Yeah?
Spring Boot 2.0 has dropped their initial actuator support, and they went to Micrometer.
Yeah, so that's what the team's looking into now. So this is still Spring Boot 1, and they really have a plan to move to 2.0, and they're looking at whether they want to move to Netflix Zool 2 or use the Spring Cloud Gateway. I'm guessing it's going to be the Cloud Gateway, because it seems to be better supported overall, because Netflix has been working on Zool 2 for years, and suddenly it's there, and there's no documentation, and it's pretty hard. Yeah, Spring does that better, I would say. And there's indeed also the actuator stuff is going to be different, but yeah. But what's actually nice is if you put this in your, if you use the actuator or any other tool, in your PCF metrics dashboard, you can actually read out those metrics right away. So that's all built in the platform. It's pretty nice. Having said all this, I said up front it took us over 2 years to get to this decision to put this platform in place and start migrating stuff. So that was really frustrating. But if we look at today, we opened up our platform in production on January 1st. We already had a dev test foundation, of course, and then we had, at that point in time, about 175 application instances. So what that means is we deploy an app, you scale it out to 2, you get 2 instances. So there was already quite a lot of stuff on dev test. Since January 1st, we're in production, and it's now May, and we have over 600 application instances running on PCF. So you see how fast this goes. It's over 70 teams today. I was presenting a similar presentation like this a month ago, and then it was 450 instances and 60 teams. So and that's the cool thing. The frustration is tremendous, but when you've got this stuff and you can give it to all the teams in the bank, and they're all using this, and you see the growth it's going through, that's really great. That's really awesome. So we're really proud that this is happening. And I think we're giving our developers a really nice stack to work with. Much more choice, much more freedom.
How many teams does the bank have?
Over 300. But not all teams are Java teams, for example. There are also still teams that work on stuff with XML transformations, BPEL, ESBs, mainframe, COBOL. So that's not everybody will be moving towards this, but there's still quite some room. We're also going into more and more digitalization. I always forget. Digitalisering. So we're actually going to grow the number of teams to be able to do that. Yeah. So there's a lot of teams, a lot of potential to grow to. Yeah. Okay, that's it. Please, of course, I should say, rate this session in the JSpring app. That's what you should be doing all now. 5 stars is enough. I don't need 6. Any questions? We have 2 minutes left. Yeah. Yeah, that's a good question. So where do we store our data? That's basically the question. Well, at the moment, we store our data still in our own data centers. So that's really awful. From the cloud environment, we hook back into, for example, an Oracle database on-premise where we store that data. Next step into moving into cloud is having persistence there as well. So we're currently setting that up, but we want to set that up in such a way that we basically get what we call a DNB approved, so the Nederlandse Bank approved databases. Because when you have high security levels or integrity levels, then it of course needs to be safe. And how is your encryption? And how is the storage? And what happens if the disk breaks? Then how is it destroyed? Stuff like that. So we are really working with Microsoft in this case. Next year also, or earlier I hope also with Amazon, to get databases out of the box that are okay, and if we have those, and we're almost there, I think, then we are moving our data there as well. Yep, does that answer your question?
Yeah.
Cool, yeah. Yes?
Sleepless nights are over now?
No, no, because then there's other stuff to, to not sleep with.
Because of the fun.
Yeah, that's true, yeah. You can't stop, yeah. Okay, yep.
What about configuration management?
What about configuration management, as in configuration?
Of the application.
Yeah, so much of the configuration management of the applications, many teams use Spring Config Server. So that means you have your configuration in a separate Git repository, for example, and or not for example, they do that in a Git repo, and then have a config server that reads it, and have your application hook into the config server to read their application data or their settings. That's the typical way how that works. Yeah. More questions? No, it was all clear. So don't do containers. That's the one thing you should remember. Yeah.